Question 42, B, Part 2. Read the question. An eagle is hovering 25 meters above point E. Since the eagle is above point E, this is a three-dimensional question. I'm going to represent the eagle by this little piece of paper, and it's going to stick out of the paper. So here, the eagle is hovering above point E. Next, it spots a rabbit at a point X along CD. X is a point somewhere along the line CD. Find the greatest angle of depression at which the eagle must fly downwards to catch the rabbit. Since the angle of depression required is the greatest one, the eagle must be nearest to the point X. And this happens when the base E is perpendicular to the line CD. X is here. So we have to solve this in two steps. Step 1, we need to find the ground distance EX. After that, we have to draw the three-dimensional triangle from X to E to the eagle. So let me draw the three-dimensional triangle first. The base is at E. X is here on the ground, and let's represent F for the eagle. We want to find the greatest angle of depression, which is this angle here. Since this is horizontal and EX is horizontal ground, it is this angle that we are after too. Okay. Redrawing the same diagrams. Step 1, look at triangle EXC. Angle ECX is 36.3 degrees. CE is 62 meters. This is a right angled triangle. Therefore, we can use opposite to the 36.3 degrees, which is EX, hypotenuse of the triangle, which is 62 meters, and this angle to find EX. Update the diagram. EX also appears in our three-dimensional triangle. Update this as well. The question tells us that the eagle is hovering 25 meters above the point E. So this FE is 25 meters. Is opposite to theta. 36.7 degrees is adjacent to theta. With opposite and adjacent, we use TOA. Inverse tangent of this value to find the value of theta. Therefore, the greatest angle of elevation is 34.3 degrees. End of question 42, B part 2.